The next law we're going to talk about is Guy-Lussac's law. Now, Guy-Lussac's law has also been known as Avogadro's law in another video that we watched. So let me show you a video example of how this works. So this is a guy on his motorcycle, and what he's doing is he's burning out his tire. And I want you to watch it really carefully. He's spinning, all of a sudden we see smoke everywhere. Why is that? Well, what happened was, as he's skidding his tire along the pavement, it's really starting to increase the temperature of the rubber. When the rubber starts to increase in temperature, so is the pressure on the inside. And it builds and builds and builds, and before you know it, the guy blew his tire out. This was actually quite predictable, and as a result of Guy-Lussac's law. So now we're going to talk about Guy-Lussac's law. Now, Guy-Lussac's law states that the pressure of a fixed amount of gas at a constant volume is directly proportional to its Kelvin's temperature. So P1 over P2, or P1 over T1 equals P2 over T2. Now another video example I have of this, and another video example I have of this is right here. We got a basketball.
Warming up the basketball caught.
Now as we can see, as the temperature here is starting to increase, if you look at the dial, you can see that the pressure is starting to increase on it. Now it's not going up particularly high right now, but we can see it goes higher, 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 and the pressure starts to rapidly expand until eventually what's going to happen to the basketball? It's going to explode. Now if you don't have these in your notes, you're definitely going to want to include them, is the idea of what is STP. STP stands for standard temperature and pressure. These are assumed values that we do, and that will equal 0 degrees Celsius at 273 kelvins, and standard pressure is known as 1 atm, or 101.325 kilopascals, or 760 millimeters mercury. So if the pressure in a container is 1001.3 kilopascals at 451 degrees Celsius, what will its pressure be when its temperature is 23 degrees Celsius? First thing we do is we list what we know. So we know the initial pressure is 1001.3 kPa. We know the initial temperature is 451 degrees Celsius. However, we don't use Celsius, we use Kelvin, so we need to convert that. So temperature in kelvins is 451 273. So 524 kelvins. We've got our second temperature, which is 23 degrees Celsius. So 296 kelvins. We're trying to figure out what the final pressure is. So now let's try that out. P1 over T1 equals P2 over T2. It's 1001.3 over 524 is equal to P2 over 296 Kelvin. So we bring that over. So 1001.3 over 296 over 524 is equal to P2. So now we'll work this out on our calculator. So 1.3 times 296 divided by 524. So that gives us a pressure of about 566 kPa.